Next we have here is expected value. Okay, so expected value is analysis of multiplying each possible outcome by the probability of each outcome that will occur, and then we do adding up. So basically definition is the expected value for a random variable x is the value of x we would expect to get after performing experiment once. Okay, and it is also called with the name expectation, average, mean value, all of them are same term. Okay, so don't get confused. So mathematically speaking, for a random variable x that can take value is represented using this. So basically the experiment that you are performing equal to summation of all the xi that you have and the probability of getting that particular x. So the expected value could be I mean it should be interpreted as the average value you get after the experiment that you have conducted as infinite number of times. Means so that expected value is actually average value of x that you get after playing the game. Okay, to understand this, let's take an example. So here what happening basically is, when we throw a dice, what is the number of outcome we get 6 outcome, right? 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6. Now what will happen, what will be the expected value that we will get if we perform 100 times, right? So let's see this in a example so we can understand better. So you can open your any Python notebook or something else, and then we'll see here. Okay. Now uh, I will be writing few lines of code that will help us get expected value for the problem statement that we have just defined. Okay, so first of all I will be importing numpy, and then I will be defining one function for our expected value. Okay, and it will take value and their probability, or you can say weight. So let's define value. So it should be np dot array, because we will be passing through a list, and then values. Same for weights. Oops. Now we will be returning after applying our formula. So what is our formula? We should be multiplying with all the you know numbers we have, we can get. So all of them are 1 into up till 6. Okay, so it should be value into weights, and then we want their sum. Okay, and then we want to also divide, right? Divide with the sum. Okay, that we have for all the probability. Okay, so this is what expected value looks like in the terms of Python. I mean, seems very understandable, right? What you are doing, you are just converting in the form of array, because we will be passing two lists. Okay, one is values, list of all the values like 1 2 3 4 5 6, and their probability, which is 1 by 6 1 by 6 1 by 6, like that. And it will it will first it will multiply with all the values and take their sum, and then we will be dividing with their sum. Okay, so let's prepare the input. Okay, so it will be value equal to whatever dice value you have. Okay, so we have all this 6 values. Now what is the probability of all this value we can get is 1 by 6. So you can just copy paste 6 times. Okay, by 6 by 6. Okay, so we are done. Now what we have to do is we have to pass it to our expected value function. Okay. I'm so sorry guys, my health is not that good. Okay, so let's call this particular function and pass our values. Okay, value is value, weight is probability. Now we want to see the outcome also, right? Okay, so let's run it. What it is saying? Okay, as np. Okay, invalid argument. Okay, yeah, now you can see you have a expected value for all the value that we have and the probability. And let's say now you want to perform uh, infinite number of times. So let's say that infinite value is n equal to 100. Okay, so we will be iterating 100 times, okay, and recording uh, the value of expected value that we are getting. Okay, so we'll define one temporary list, and for I in range, and we will append the value of temp. Okay, and at last we will calculate the mean. Okay, that's why we were saying mean or balance value. All these are same name. So we'll print np dot mean of temp. So let's run this. Okay, and print the I value so that we'll see at what iteration it is. Okay, you can see number of iteration it is running up till 100 you will see. Okay, and now we can see our value comes around 3.5. Okay, so it might be not visible, but I will make it. Okay, now you can see our value is 3.5. even if we perform 100 time or 10,000 time, whatever it is, whatever the expected value that is expected for the first run, it is it is like advised that even if we perform 100 times or 200 times, that particular value, the expected value that we have created, we can get the same value. Okay, so that is what expected value is. Next we will see binomial distribution.